In my minimal API, I have 3 endpoints. One is singleton, or it does it call the WCF service incrementally, and then I have singleton async, which call the WCF service asynchronously, meaning it uses the async await, as you can see. And then I got the third one, which actually calling the WCF service using the async method, but it used the GetAwaiter and that GetResult. So task.run, which will schedule this work on a worker thread, which is a background thread. So these are the 3 methods we're going to compare. I am going to show you by running a load test. I have created 3 load test profiles. The first one is singleton sync. So it's a simple script here. That's where the API is going to be exposed. This is the base URL. It's going to introduce start with the 10 users, and within 10 seconds, it's going to ramp up to 200 users. And then for 30 seconds, it's going to stay at 200 users. And then the last 10 seconds, it's going to ramp down to 0. So all 3 singleton task run has the same profile. Singleton async has the same profile. So I have already started the Docker. My service is running right here, as you can see. Now let's go back to the thread pool config. So I have created this one. I'm going to run this one first to show you what is the thread config, thread pool config right now. So let's see. So we have minimum worker threads of 6, minimum IO threads of 1, and then max is this maximum number, and then 1000. I have not changed intentionally here. This is empty. So this is what, based on the number of cores available to the Docker setup, multiplied by 2, I think. So 3 cores was multiplied by 2, 3, 6 worker threads we got. And here on this side, I have Docker terminal opened. And in this one, I'm going to start the .NET counters. It's going to come up shortly. So we're going to watch this. Let's minimize a little bit of this one so we can see all the numbers. So these are the 3 numbers which we're going to notice. Hopefully you can see it clearly. So this is the thread count right now. This is the queue length is 0, and this is the worker item. This is the IO threads which will get completed. Okay, so what does thread pool have? I'm going to show you a little picture right now here. So see that thread pool has minimum worker threads, minimum IO threads, maximum worker threads, and maximum IO threads. Worker threads gets your request and does the work if any processing needs to be done until you have to read from the external process or external socket, let's say. So it will hand over to IO thread, and it depends how you are using it now. If you're using an async way, it will get free, and then it might do some other work. Meanwhile, the IO is blocked, and then once the IO is done, I will call back and post the context, or give the context of that thread and resume on the worker thread again. But if you're doing sync way, the worker thread will be blocked IO thread while the IO thread is doing the work. And same thing with the task.run. It's just that task.run schedule it to make sure it's scheduled to the thread pool thread in the background. So this is a little picture here. This is the time, and this is the number of threads. Let's say your application starts here, 0 threads, and at 0 seconds, as soon as the load increases, you are sending more requests, then number of worker threads keeps increasing slowly. So it will, as long as you are in the green area, which is the number of requests or number of worker threads required to do the work is less than the minimum threads, you are in the green, and there is no problem. Your application is fully healthy. You are utilizing the full resources here. But as soon as you go to the yellow area or yellow zone, what's going to happen? The hill climbing algorithm going to kick in. It is very complex algorithm, but it's open source, I believe. So here, what you're going to see is that now the .NET runtime will see how many threads are getting out, are completing the worker items, which is IO threads. And then based on that, it will introduce a thread every half a second. That's the general algorithm says. So every half a second, it will introduce a new thread until, so here it kept introducing, but suddenly all of many threads got completed, and then you are in the green zone again. But again, a burst of requests came in. Now it will go up like this. So once it go up like this, you might end up here. So this is the danger area. Now your application is literally hang because you have reached the maximum number of threads and there is nothing else. There will be no new threads and you will literally hang. But somehow if the number of threads gets completed, you will be back here, and until you get back into the yellow zone, you are not safe. So this is how the general outline of thread pool min and max worker threads. So we have seen here. Let's get this out of our way and let's open the terminal. First of all, I'm going to run a load test. I already have a script here. I already showed you. So singleton task run singleton async.js. So singleton async.js. Let me show you singleton sync. Let's go back to singleton async is this one. You can see the name. So same profile, nothing fancy. We're just getting the request. So I'm going to start it. So we're going to wait for 10, 40, 50 seconds. So while we're waiting 50 seconds already in the terminal, we have, in the Docker terminal, we have the .NET monitor running. So I'm going to start it here. So it's starting. We can also check the logs if we want to. We can come here. You can see the requests are arriving. And the 200 responses are being sent back. So if you notice here, the thread pool queue length will not go above 0, because even if it goes, it will suddenly come down. That's the ideal way, and we are ramping up to 200 requests at any given time, and it is managing it pretty well. Remember, our thread pool config was, let's go back to run it again. Thread pool config here, what was it? It was 6. So minimum work is 6. So we are sending a lot of requests since our worker thread is getting free, and it can do another work, any other work for another thread while it is reading IO. And remember that we have a nice bit up here. So if you go here, I have introduced a timeout for 2 seconds for the WCF client service, and if we go back to the ping service, it will return between 1.5 seconds. So since we are calling async, we shouldn't face any exception, any timeout or whatever. So let's go and go back to terminal and see what happened in 40 seconds. And request sending, requests failed, 0%. So we got this many requests successfully processed. Response time here, we can check later, but that's not the area of contention here. So it doesn't really matter. So since we have the random number here, so it's between 1 to 1.6 or 7 seconds. Now let's go back. So this one was a successful run. Now I'm going to run the same test here. So it is, I'm going to say task run request load test.js. Task run JS. So task run load test JS has the same profile. There is no difference. Let me show you. Task run is here, singleton task run, right? So it's K6 based script is pretty simple. So we're gonna run the script and see. So I'm not in the load test directory. What is it? K6. Okay, it's named singleton task run.js. Not I was looking at the singleton task run.js. No, we have to watch this, our thread pool config. See, the queue length this time have jumped really, really quickly. We are at 10-second mark, and we are at 200 virtual users, and it's a steady load now. It's going to stay for 30 seconds. And you see here that the number of queue length is 131, and the current thread is 130. It is increasing, and then the work being done is less and less. And you will see that these threads are waiting. You know, there is a work for the to be done, but they are waiting for the threads. That's what it really means. So now it cleared all the threads because we are into the end. Now you see the thread pool queue length drop to 0, and now the thread count is 203. It will slowly come down. I will show you quickly that how many errors probably have occurred already. We already saw that async version worked perfectly. Let's go up here. So there were 1.71 failures, and you can see that only 458 failed and 8 succeeded, and the response time must be crazy, right? So look at that. So this was not a good test by any means. Let's go back to the service and see what the Docker is telling us. So the thread is count to 0 now. If you keep going up. So what we see here, still executing. I don't see any 200 responses here, meaning most of the test is just a literal failure. Well, what can be done? Nothing can be done. So right now we are at thread count of 6, which is good. And let me just simply run a get request that services responses. Yeah, it does respond. Okay, good. Now we are moving to our third thread, which is the actual case that we are calling async because it is a migration, and we cannot afford to migrate all the way async. Let's move quickly and run the test here. So this is gonna fail miserably. Singleton sync. You see here the pool length already jumped 54, 55, and we are at the 10-second mark. It's gonna really jump high. It's 120 now. So now it's steady state, meaning a 200 requests. We only have 6 worker threads. So a lot of work needs to be done, but the worker threads are not available because they are blocked because we are reading the IO. So when IO is done, IO is getting done in 1.5 seconds, between 1.5 seconds. When it comes back, only then the worker thread will get free. And thread pool is only injecting threads every half a second. You see that your application is really now in a mess. So let's go back to the log and then just delete it. You will see a lot of errors, timeouts happening. So request finished, 200. Now we are at the end mark. That's probably why. It's 63 count, still going down and down. Let's go back to the terminal. So what happened here? So 86% failed. Okay, so in the sync all the way, 86% failed. In task.run, only 1.8% failed. Let's go to the task.run here. So 1.7%. In the async one, how many failed? 0, because we didn't see any QLAN. Now, for whatever reason, not whatever reason, there are many reasons that you cannot migrate because of the time constraint, or you don't have enough time to test, or don't have enough automated tested to make sure that this will still be stable, or the application is not really on hot path and it's low priority. It is all about value. Now, let's go back and which version we want to fix first, because I don't want the video to be long. So what I'm going to do here is I already have an endpoint. Since we are at the 200 users, I'm going to go here. I'm going to stop and open it again. So we are adding 200 users. I'm going to just make it 500 here, and I'm going to 500 here. If you have not noticed, the CPU was really low. That's the indication. If CPU is high, if the memory pressure is high, then you have other problems along with the thread pool. But the correct detection of the thread pool would be if your CPU is stable, if your memory is stable, there's no high percentage of garbage collection, but your queue length is going up, and application is responding, and a lot of errors are happening. So we already saw that the WCF client was timing out, although the server is supposed to respond back in 1.5 seconds, and the timeout was 2 seconds. Still, it's timing out. Now I'm gonna run this one and see what's gonna happen. So we got it. Let's run this again. So now if you see here, I have 500, max is 1,000 and 1,000. I hope that we will never reach 1,000. Now I am going to run the worst version first, because we saw that it had 86% failures. Let's go back here. Let's just remind you, 86% failures. And I am going to run it again. The thread pool is stable. So it's singleton sync. Let's see what's happening. So let's see if the full thread queue length is jumping. Now the CPU is 5%, the garbage collection is 0%, the thread pool has not jumped yet. And if you see here that the 127, the thread pool is adding the threads as needed. That's why we are not seeing any jump in the queue. Let's quickly check in the here. So if you see here, so 200, a lot of 200 requests earlier. I believe if we set this, and we can see that CPU is 6%, pretty good. Garbage collection is because we're not doing much, but in the scope of big applications, that can also attribute to other problems, and you will have to diagnose each one. So test is finished because we're only running 40 seconds. Let's see how many percentage have succeeded. So request percentage was 0.0%. And remember, we are running the worst version, so we're running the sync request. And what's the response time? So response time max is 15 seconds, which is ideal, right? Because what is happening here is that whenever there was a worker thread needed to perform some work in the process, thread pool immediately provided it, because we set the minimum number of threads higher, and we were always in the green zone. We never actually went to the yellow zone because our minimum thread threshold was never breached. So that's the idea. So I'm just gonna, just for example, I'm going to run a async version with the same configs. So it was already 0%. We can simply check how many requests it actually, 0 is 3665. Let's run it for 40 seconds. So we can see on the left side that the thread pool is not jumping. And interestingly, you will notice that here, the thread count is really low. While when we were running sync, a lot of threads were getting created. And because they were getting created and getting blocked immediately, they were not doing any work. So there were a lot of many threads in the thread pool, but they were blocked because we are reading from service, it's doing the IO, and they were getting unblocked. So the thread pool was high, but if you are doing CPU-bound work, then it is a problem. Then you will have a lot of context switching. The CPU is already busy, so that's gonna pose a lot of issues for you. So let's see what we got here. So we got slightly higher. It doesn't really matter because we are only sending a limited number of requests. We are not trying to test the boundary of the throughput. So it's 3671. Earlier we had a little bit less in the async one. This time 3665. Well. Then look at the response time is between 1 and 1.5 seconds, which makes sense. Yeah, it's only 5 more requests. So same thing will happen with the now task run. Let's run the task run one the last time. So you will notice that the thread pool behavior. So see how the thread count is increasing. For the async, it only stayed 8, 9. There were not many threads. But for the async, pure sync all the way one, it went really higher. Now for the task run, it is also going higher, and it's on 131, 132. But our minimum is never breached. We are not in the yellow zone, so we are not facing the delay mechanism. You can actually disable the hill climbing algorithm altogether as well, but I have never tried it yet. Maybe another time. Well, that's pretty much it about how to detect thread starvation. It's totally in isolation because in regular application you would need a lot more sources. I hope you will like this demo. I try to make it really quick. I will push the source code in the GitHub repo, and later on you can find it or you can ping me there. All right, thank you very much. Bye.